This video is for Nova Online Math 161 and we are reviewing for the final exam. And the topic that we're covering in this video is graphing quadratic function. Identify the vertex, axis of symmetry, and intercept for the graph of the functions. So I have two prepared here for you, f of x and g of x. Let's work with f of x first. Let me copy this over here. And we are finding the vertex, okay? Write the vertex formula that we have x equals negative b over 2a. This will give us the x-coordinate of the vertex. So b is negative 4. So if you make negative 4, you're going to get positive 4 on top of the fraction. Now in the denominator, you're going to do 2 times a value of negative 1. 2 times negative 1. And now let's simplify that. That is 4 over negative 2. So the x-coordinate of the vertex is negative 2. Now we have the x-coordinate. Let's go find the y-coordinate. If you want to find the y, plug in that x that we just found into the function. So if you plug in negative 2 squared minus 4 times negative 2 minus 5, what's that going to give us? You are allowed to use a scientific calculator. So on the exam, if you can use scientific calculator, if you have one available, you can go ahead and use it. So let me type that in. Negative 2 squared minus 4 times negative 2 minus 5. So the y-coordinate comes out to be negative 1. Okay, so we found the vertex. Okay, I will say that the vertex is at negative 2, negative 1. Okay. Well, not just that, we also found the axis of symmetry. Axis of symmetry is always the x-coordinate of the vertex. And the x-coordinate of this vertex was negative 2. So you say x is, or x equals, negative 2 for the axis of symmetry. Now, what were some other things they wanted? Let's take a look. I forgot. So I'm going to go zoom out. And it's asking for intercepts for the graph. Okay. Now, let's go find some intercept for this graph. I don't think we are graphing them. Yeah, we're just finding these important parts. But we're not graphing these. We're just finding the vertex, axis of symmetry, which we found right here. But now it's time for some intercepts. So if you want to find the y-intercept, you're going to plug in x equals 0. So plug in x equals 0. Because y-intercept happens when the graph is on the y-axis, right? To be on the y-axis, you cannot go to the right or left. So that's why the x-coordinate has to be 0, okay? So let's plug in 0 into the function. Y equals negative 0 squared minus 4 times 0 minus 5. The first two terms will just go straight to 0, leaving us with negative 5. So we have a y-intercept of 0, negative 5. Now let's go find x-intercepts. Now if you want to find x-intercept, this may be a little bit more tricky. So x-intercept, you want to set the entire function equal to 0. Okay? So if you want to find x-intercept, set y equals 0. But that will give you 0 equals negative x squared minus 4x minus 5. Now some quadratics are factorable. If they're not, then we may have to use the quadratic formula. Let's try to see if we can factor this, okay? So I'm going to factor negative out. I'm going to factor the negative 1 out. When I notice the leading term is negative, I decided I'm going to factor out the negative, so all of them will switch to the opposite sign. So negative x squared will turn into positive x squared. Minus 4 is now positive 4. And negative 5 is now positive 5. Now let's factor this. We're thinking two numbers that multiplies to be 5. Well, they have to be 5 times 1, nothing else, right? But now we got a problem here, okay? If I make them both positive, look, if I make them both positive, They will multiply to be 5, but will they add up to 4? No. So we got a problem here. So they will actually add up to 6. So I'm thinking, can I make them both negative? Let's see if I can change Z to both negative. If they're both negative, negative 5 times negative 1 is positive 5, but they will add up to negative 6 this time. So is this factorable? No, it's not. So, you know, what you can confirm, and I'm trying to do this completely graphing calculator free. What you want to confirm, remember I remember it was quiz 2 or 3. You guys talked about discriminant, and depending on the sign of the discriminant, you can tell if it has a solution or not, okay? So, what we're going to do is to check for b squared minus 4ac. If that pink b squared minus 4ac is negative, we can say this has no solution. So we're going to conclude that it has no x-intercept. So let's find that discriminant to see what the sign we get, okay? So I'm going to do negative 4 squared minus 4 times a of negative 1, c of negative 5. Now, what's that going to be? Okay, so if you just evaluate that, I'm going to do negative 4 squared minus 4 times negative 1 times negative 5. Look at that discriminant. It is negative 4. Okay, so the discriminant is negative 4, which tells us this quadratic equation has no solution. Okay, so at first I try to factor this. When it didn't factor, before I jump into the quadratic formula, I just wanted to see if this equation even has an answer, a real answer. And you can't have an imaginary x-intercept. You can't plot imaginary dots on the x-axis. So when that discriminant came out to be negative, this is when we get to say no x-intercept. No x-intercept. Now, I do want you to think about this graph though. What I'm going to do is I'm going to try to sketch it for you, okay? Look, this graph has a vertex at where? Negative 2, negative 1. So you're going to go 2 to the left and down 1, right? So that's the vertex. Now, this is a negative parabola. So that means this parabola will open downward. So you're going to have something that looks like that. Now, is it clear why it doesn't have x-intercept? Because it starts as low as negative 2, negative 1. And the parabola goes downward. So it will never go up to touch the x-axis, okay? So that's why, graphically, this graph will not have any x-intercept, but algebraically, we can confirm that by finding the discriminant sign, that when the discriminant is negative, this quadratic equation will not have any solution. Now, I don't want to make these videos super long. So what I want to do is I'm going to stop this video here. And I will start another one going over the other case, this g of x. Notice they're very similar, but I wanted to give you 2 examples on this topic because, you know, you may run into either of them on your final, okay?